Alright, so what I want to look at today is introducing the Pearson product moment correlation. Okay, the correlation coefficient. Most of the time, if you hear someone talking about a correlation coefficient, this is kind of the most common one that they're using. Alright, now a correlation coefficient, you might see this referred to as Pearson's R. Okay, an R value. If you put data into your calculator and you run two variable statistics, okay, have you guys ever used that on your calculator before, the two variable statistics? Okay, we'll do that and we'll look at that, but you'll see an R value, and that actually is this value that we're looking at. Okay, now we mentioned yesterday that R, the correlation coefficient, is going to go from -1 to +1. Okay? How would we describe something that had a correlation of -1?
Weak.
It's negative.
Negative correlation.
It's a perfect. It's actually opposite weak. It's very strong. It's perfect negative correlation. Positive one would be perfect positive correlation. What's the no correlation? Zero. Okay? Now, theoretically, any data you get, if you run this test, you're going to get something. Okay? Getting exactly zero is basically impossible. But you'll get really, really small numbers, and you can say that there's no correlation, essentially. And what we're going to focus on is actually whether or not correlation is statistically significant. Okay? Yes?
Will this be in our quiz on Tuesday?
The concept of correlation, I'm not going to have you calculate an R value, but the concepts involved will be there.
It's going to be mainly on variance and standard deviation, right?
The cumulative frequency, variance and standard deviation, and the concept of correlation. Okay? I'm not going to have you calculate these yet for the quiz. Alright? But I may say, I may give you a scatter plot and ask you about the correlation or something like that, or I may ask you to interpret something. But let's look at some general guidelines. Your book provides this. The Pearson product moment, we use R to represent this value. And some general guidelines for strength, okay? Notice here, an R value of 1 is perfect, we already said that, okay? 0.95 to 0.1, you don't need to try to memorize these ranges, okay? But just see that we can categorize them as very strong, strong, moderate, weak, and no correlation, okay? And you'll notice here, because 0 is basically impossible to get, they give us a range, like -0.1 to +0.1 is basically no correlation. These are not good enough descriptors when you are doing, or if you decide to do some kind of a correlation test for your IA, okay? Because what does this not take into account?
Outliers.
Well, it would take into account outliers, actually. I mentioned something yesterday.
The difference
No. This doesn't take into account how much data we got these numbers from. Okay? This is a general description of strength, but it doesn't take into account whether we had 5 people or 50 people. Because here's the thing. I could have 5 people and get a 0.9 as my correlation, but that not be statistically significant. Okay? And you might say, well, 0.9 is really strong. Yeah, but we only had 5 people that we got that from. We could have had 5, or 2 of the 5 could have been an anomaly. all right? If we get more data, like 50 people, then a 0.9 would be an incredibly strong correlation. In fact, with 50 people, you could even have like a point, I forget what the actual number is, but like a 0.3 or 0.4, which according to this would be in a very weak, but because you got that from so many data points, we could say it was statistically significant, okay? But we're going to look at how to determine that later here today. But I wanted to mention this. Now, when can we use the Pearson product moment or the Pearson's R value? All right, we can only use this when we're dealing with interval or ratio measurements. This is going to be really important, okay? Because it's really easy to want to use this with ordinal data, okay? You have your friends rank their subjects, from easiest to hardest, and you're trying to find a correlation with how hard a class is or something, I don't know. You're having them rank them, that's ordinal data. You can't use this, okay? So you have to just be careful that you're using either interval data or ratio data when you're doing this, okay? So, let's talk about hypothesis testing, and then we'll look at the formula for our R value and how to do this whole hypothesis test, okay? Now, how many of you have done a hypothesis test in physics or some other science class? Okay, so you're somewhat familiar with the concept. All right, so what we're going to suppose is, we call this H sub naught, or our null hypothesis. Our null hypothesis assumes that there is no correlation. All right? You might say, well, if we're trying to show correlation, why would we assume there's no correlation? That's just kind of how it's done. All right? The alternative hypothesis we call H sub 1. That's going to assume there is a correlation. And when we're talking about this, we're saying statistically significant. Okay? So, now, here's the thing. When you're doing a problem, you're not just going to say, suppose there's no correlation. You need to adapt that statement to whatever the situation that you're dealing with says. Okay? So if you're trying to find a correlation between age and shoe size, you should say, null hypothesis is there's no correlation between age and shoe size. Alright? Your alternative hypothesis would be there is a correlation between age and shoe size. Alright? Next thing that you're going to do is calculate the R value. And that we'll look at in a moment. Then we have what are called degrees of freedom. Okay? For the Pearson's R, you're going to use n minus 2. Now what's n? The number of numbers that you have, or data values that you have. Okay? So degrees of freedom are important to identify. You're going to use n minus 2. So if you have 30 people, then how many degrees of freedom are you going to have? 28. Okay? So you got to identify that, and you're going to write that down, because you're doing basically a little report here. So, you write down your degrees of freedom. This is going to help you find a value from the table that we're going to look at that will help you determine significance. Okay? That value of significance provides us with a value to determine our region of rejection. Okay? Now, all this is, region of rejection, means it's a range of values for R where we will reject the null hypothesis. Okay? So that number you get out of the table that we're going to look at is called a critical value, and that value is the minimum value R has to be in order to reject the null hypothesis, okay, that there is no correlation. Does that make sense? All right. Now, one of the things that you will see if you look up, critical values or something like that online, you'll see various levels of confidence. And depending on what you're studying, you may want a different level of confidence that there actually is a relationship. Okay? For example, in our class, we're going to use 95% confidence. So when you're looking at a table, you'll probably see a 0.1, 0.05, 0.01, maybe even a 0.001. You're going to take the numbers out of the 0.05 column. Okay? That make sense? That make sense? Okay. Now, if you were doing testing a new drug, would you want to just be 95% sure?
No.
No. So you would probably use a 0.1 or even 0.01 or not a 0.1, that would only be 90%. A 0.01 or even a 0.001. Okay? For that table. Okay? So depending on the thing that you're studying, you may use a different column of the table. If it's something that's really not all that critical, you might even use a 0.1. That way you'd be 90% sure there's a correlation. All right? And then basically at that point, once you identify that, then you can compare your R to the region of rejection and draw a conclusion. Yes, there is. We reject. Our R value is greater than the critical value, so we're going to reject the null hypothesis and accept the alternative hypothesis. Or no, our R value is less than the critical value, so we're going to accept that there is no correlation. All right? Now, let's look at the formula we're going to deal with and break it down because it looks rather complicated, but it's not nearly as complicated as it looks. Okay? One thing I will tell you though is that for the IB exam, all right, if you look on the formula sheet, which, let's go find the formula sheet. Formula booklet. If we go down and look at correlation, okay, functions, equations, there's the trig, vectors, statistics, and probability. Okay? You'll notice there actually is not the formula. Okay? Now that doesn't mean you have to that doesn't mean you have to memorize it. That means on the exam you will not be asked to do this by hand. Okay? I'm having you learn how to do it by hand because if you were to use a correlation for your IA, you can't just use your calculator and say, my calculator told me, because then you're not actually doing any math. Okay? So I want you guys to see this done by hand because it is the R value we learn and we interpret with quite a bit. We're going to look at how to do this by hand. So let's look at the formula. We have n times, and then there's a bunch of these sums. The sum of x times y minus the sum of the x's times the sum of the y's all over there's this big square root, okay? It's n times the sum of the x squares minus the sum of the x's squared. Be careful with your squares here. Times n times the sum of the y squares minus the sum of the y's squared. Okay? Now another thing I will say is that there is another formula that will give you the same value. It looks a little bit different. Okay? This is the one I've learned to use. The other one is, you know, no better or worse. It just is different. It looks different, but it calculates the same thing. So if you're looking at stuff online and you see a different formula, that's just the different one, okay? So what does all this mean? Let's take a look at how we can stay organized and make sure that we don't mess stuff up along the way, okay? First of all, anytime you're given a correlation or you're finding a correlation, you have to have, we call it bivariate data. You have to have two variables that you're comparing. Okay? And I would recommend making a little table like this. Here I have points of 4, 4, 5, 6, 3, 5, 6, 7, and 10, 7. Alright? For right now, this is just some nebulous situation. We don't really care about the situation right now, we'll just focus on the numbers. So what we're trying to determine is there a significant correlation between the values of x and the values of y? And you'll notice the first thing I did was actually find the sum of all the x's and the sum of all the y's. Because that shows up here, and here, and here, and here. Okay, so we're going to need those numbers. Now, looking at your formula, what else are we going to need to do?
Sum of x times y.
Okay, we need to do the sum of the x times the y, so we need to multiply all the x's by the y's, right?
Yep.
So 4 times 4, 5 times 6, 3 times 5, 6 times 7, 10 times 7. Alright? So let's fill that in. 4 times 4 is 16. We have 30. We have 15, 42, and 70. Okay? Now those individual numbers aren't going to matter so much because what we need is the sum. Alright? So we add all these up. Okay? So 61, 103, 173. Okay? Is everyone with me so far? Okay. What's another thing we need to do and then add up?
Square root. Square, just square them. Yeah, the square.
Okay, yeah, square them. We've got to square all the x's. We've got to square all the y's. Alright? So, if we square the x's, switch back to blue. 4 squared is 16, 5 squared, 25, 9, 36, and 100. And we've got to add all those up again. Okay? Let's see, that's 34 and 16 is 50, so that's 86, 186. You guys can double check my arithmetic. Okay? 50, 86.
Yeah.
Okay? Then we do the same thing with the y's. 4 squared, 16, then we have 36, 25, 49, and 49. I almost made a really common mistake. I almost put in 10 squared instead of 7 squared. Okay, be careful you don't mix up what column you're in. It's an easy thing to mix up here. Okay, so now we add those all up. All right, let's see, that's 52 and that's 98, so that'd be 150, 175. Okay? So now, here's the cool thing. We've got all the numbers that we need to plug into our formula. We know n is 5 because there's 5 pairs of data. Alright? So now we simply need to plug it into the formula. So I'm gonna, you guys try and see how well you do. You're gonna need your calculators. Okay? Give it a try. You don't have your calculator? Alright. Well, I know, but you need to get one.
I'll buy one, sorry.
Okay. Or borrow until you can get yours back or something.
Do I need it for the Fusion Day quiz?
Well, yeah, to do your standard deviation,
So I need
you're gonna want to be able to. Go away. Here's my calculator. There's my calculator. There we go. One of the keys to getting this right, even with your calculator, is not trying to do too much all at once when you're punching it in. Okay? So, just be careful. Oh.
Put parentheses to square.
Hang on. No, hang on. Clear that. Be 5 times. There we go. There we go. So we should have.
And you just square root it, don't you?
Yes. We'll need the square root here. I'm going to write down kind of the intermediate value here. So R is going to be, did you get 53 for your numerator?
Yeah.
Okay. And then we got the square root of, what was it, 496? 4964. Okay. So now we can divide 53 divided by the square root of 4964. You get 0.7522.
Yep.
Okay? Now, one of the things here, you do not want to round very much, all right? Because the decimals that we're dealing with, remember, everything's between -1 and 1, okay? So we've got to go out to a few decimal places. So I would say at least do 4, maybe even write down 5 decimals, okay? We get 0.75225 if we go to 5 decimal places, okay? Seven, 5, 2, 2, 5. Now, according to that table we looked at the beginning, 0.75 falls into the moderate correlation, okay? But that doesn't really matter. We want to know, is it statistically significant? So, let's work our way through our hypothesis test, and here we'll actually see a region of rejection, okay? So, what would we say for our null hypothesis?
There is no correlation.
There is no correlation between, in this case, we don't really have a situation, so we'll just say between X and Y. All right? So our alternative hypothesis is there is correlation. And we could say a significant, okay? Significant correlation between X and Y. Okay? So we've got our null hypothesis, we have our alternative hypothesis. How many degrees of freedom do we have? Okay? Good. We're going to do 5 minus 2. So we have 3 degrees of freedom. That's a key. What? We take n, which was 5, minus 2. It's always minus 2 for this. Okay? And by the way, each test calculates it a little bit differently. Like if you do a chi-squared, it calculates it differently. Okay? So, how do we know what our region of rejection is? Well, that's where we have what's called a critical value table. All right, now you have here a level of significance for a two-tailed test. Okay, that just means both ends are possible. All right. Here's that 0.1. That means we would be 90% certain that there's a correlation. Here's a 0.02. That means we'd be 98% certain there's a correlation. For our examples, unless we're specifically told otherwise, we're going to be using this column right here, the 0.05, because that tells us that we are going to be 95% certain there's a correlation. Now, how many degrees of freedom did we have?
3.
3. Okay, so we have 3 degrees of freedom. So the number that we're looking for is right here, the 0.878. Okay, so let's go back. Now that we know what the value should be, the region of rejection is R greater than or equal to 0.878. Okay? R we found to be 0.75225. Okay? 0.75225. Okay? That is outside the region of rejection. Therefore, we will accept H sub naught. Okay? Or we will not reject it at least. Okay? We're going to accept that there is no significant correlation. Okay. And yes, you should write out your conclusion, okay? Communicate. There's no significant correlation between X and Y. Okay? Yes?
How do I know it's 95%?
How do we know it's 95%? Because it comes from the column with 0.05. What this means is there is only a 5% chance, if we use this column, it means there's only a 5% chance that our data is really skewed and that's what gave us our results. Okay?
But why don't we use the 0.1?
Because that would only be 90%.
Oh, what about 0.02?
That would be 98%.
Yeah,
Okay.
So should we do more accurate?
Well, for our purposes, and unless you're told otherwise, and this is just my decision, we're going to use the 0.5%. Okay? Or the 5%.
Well, we have this table during the test.
Oh, yeah. Yeah, you don't have to memorize the
And
table.
we always, and normally we will use the 95%.
Yeah. Okay? Alright, does that make sense? Okay. Let me bring here. I want you to try one more of these. Just try it start to finish on your own, okay? Here's some other data. Again, we're just keeping it generic X and Y. Alright, but try to take it start to finish on your own. Okay?
Whoa, what happened here? Okay. Alright, now. Alright, you too.
I'm sorry.
Alright, see ya. Okay,
Good weekend.
thanks, you too.
Okay, it's a head start, so I'll start filling in some. 77, 958, 970, 958, 983.
What does N represent here?
N represents the number of pairs of data. Okay, so, and that's actually something that may be a little confusing. You might say, well, there's 8 X's and 8 Y's, so N is 16. It's 8 pairs of data because you have what we call bivariate data, 2 variables.
Okay.
So it's like a point.
Alright.
Okay. Now, are your numbers matching up with mine?
Yes.
Yeah.
Okay.
Yes.
All right, good. So, have you guys gotten R yet, or you still working on it?
Got the top one.
You got the
I
top
got
done?
negative for top, so
That's okay. That would mean there's a
negative.
negative correlation, right? So, oh my.
Put that back together.
Okay. So what did you get for the numerator?
Negative 291.
291. Is that what others got?
I'm not there
Not
yet.
there yet.
Out there?
Yeah, negative 291.
Okay. I would say at the very least to show your work, make the table. And as we look at how to do this part with your calculator, at least write down what all the sums are. Okay? Write down what those sums are. This is the sum of the x's. Here's the sum of the x squareds. You know, here's the sum of the y's and the sum of the y squares. And then here's the sum of the xy's. So when you're showing your work, I expect to at least see those 5 sums. And then as you're calculating your R value, show me what you got for your numerator and what you got for your denominator before you square root it. Okay? So what do we get for our denominator here?
Yes. Not there yet.
Okay, that's okay.
106,713.
Call Manus, please report to the middle school office. Call Manus, please report to the middle school office.
I got a really big number.
326 point.
Well, hang on. What did you? 106,700.
Did you get like 2 million?
13?
Yeah, 226619433.
Yeah, that's
I
right.
got
2266.
19433.
Okay. That what you got?
No. I got like 2 million something. It was like 2 million.
What'd you get?
The
Well, that's
top one.
226 million.
Oh no, then I got like 2,270,033. Like I didn't get any. No, it's much smaller than that.
Okay. Well, let's
Let me see what I did wrong.
let's come to a consensus here. Let's see what we've got.
I did 354,647 times 639.
Okay.
I got 639, but I got 167 for the first one.
Well, let's work this out. Okay. This is fine. I mean, this is why we're doing this as practice. Because honestly, punching this into a calculator is half the challenge. So we have n times the sum of the x squares. So 8 times 211
106,000.
minus the sum of the x's, which is 39 squared.
Oh, I swear.
Okay, and it's not recording anything. Hang on.
That's what it was.
Once we get an answer that matches, we'll go with it.
No, I see what I did
I
wrong.
got 106,713.
All right, good. So we
Square
got the same thing.
Yeah, I'm definitely wrong. Our
Okay.
is way too big.
No, I now I got 106,713.
Okay, good. We 3 people got it, so we'll go with that. Okay, so we have this, and then what does that end up equaling? R equals
0.89.
0.
Negative
Negative 0.8.
9.
Give me like 4 decimals. Okay.
0, 8.
908.
Yeah.
Okay. Always give at least like 4 decimals, because remember a critical value table has 3. Okay, and that'll help us with any rounding issues that we may run into. Okay. So
So,
our hypothesis, our null hypothesis,
6, 7.
is there's wait what?
Oh, I'm sorry. We're doing the hypothesis. I was doing the
Oh.
numbers.
Oh, the degrees of freedom.
Yeah.
Okay. Our null hypothesis is,
There will be no correlation.
yeah, there's no correlation between X and Y. Okay? Our alternative hypothesis is,
There is a correlation.
yeah, there is significant correlation. Now, real quick, degrees of freedom would be
6.
6. All right. So we need to hit at least 0.707. Okay. So the region of rejection is R is greater than or equal to 0.707 because we had 6 degrees of freedom. So what's our conclusion?
No, it's negative.
Well, sorry, absolute value of R would have to be.
Yes.
So yes.
So you can
Okay.
also-
So yes, we would accept H sub naught. I'm sorry, we would reject H sub naught and say that H sub 1 is correct. There is a significant correlation between X and Y. Alrighty. Have a great long weekend.